Here's problem A2. A 2 kilogram block slides down a frictionless incline from point A to point B. A force of magnitude 3 newtons acts on the block between A and B as shown. Points A and B are 2 meters apart. If the kinetic energy of the block at A is 10 joules, what is the kinetic energy of the block at B? Let's start with the one equation to rule them all. Kinetic energy at A plus the potential energy at A plus any work done along the way should equal the kinetic energy at B plus the potential energy at B. Let's try to evaluate these terms. First of all, let's set point B as being our zero height. So that means, with no springs involved, that the potential energy at B would be zero. And then that would set up our potential energy at A as related to this height here. In other words, our potential energy at A is going to be mgh, where h is equal to that pure height above point B. Well, that height is going to be equal to the hypotenuse of this triangle, which is 2 meters, times the sine of 30 degrees. So that's going to be 2 sine 30. Sine of 30 is 1/2, so that's going to be 1 meter. So our potential energy at B will be related to at A, will be related to mgh, where h is equal to 1 meter. Sounds good. Kinetic energy at A is given as 10 joules, and we want to find kinetic energy at B. So right now we've got that 10 joules plus mgh plus the work done along the way, which is going to be the work done by P. That's going to be P times D cosine of the angle between them, let's say alpha here, is equal to the kinetic energy at B. Well, P is going this way, and D is going this way. So the angle between them is going to be 180 degrees. So this alpha that I've written here is 180 degrees, and this cosine then of alpha is going to be a -1. So now we have that 10 plus 2 times 9.8 times 1 meter plus P, which is 3 newtons. The distance D is going to be 2 meters. And we'll just write this in. Cosine of 180 degrees is equal to the kinetic energy at B. Alright, so cosine at 180 degrees is -1. And now our equation looks like this. 10 plus 19.6 minus 6 equals the kinetic energy at B. Or the kinetic energy at B is equal to 29.6 minus 6, or 23.6 joules. So, we started with the one equation to rule them all. We tried to evaluate our terms, and then we came up with that the kinetic energy at B is 23.6 joules as this block slides down this incline.